Hello and welcome back, PlayBASIC coders. We're into a development blog today, so buckle up, it might get a bit complicated. The last few days, in fact the last couple of weeks, I've been doing what I consider to be the cleanup work, the final work of the 165 releases. Those things have had, hopefully you've seen some examples on the forums about adding missing blend modes, rounding out the command sets, fixing the allocation problems inside the mapping libraries, and then that's led me to the work for the last, I think it's been the last probably 4 days, 5 days maybe. One was trying to work out why this particular library, in this case this XOR's library, was failing to compile. Long story short, that library has an internal dependency upon Direct3D, and it has a fixed version of Direct3D that it likes. If you don't have that in your system, the library won't load. So you would need that DLL with you, and I'm not sure you can just, like in the old days, you could just ship those DLLs with your product and that would work, but you still need the DX9 driver on it. I'm not sure these days. Anyway, a second problem with that was that 165 was failing to build. Like it wouldn't even run with one include file. If we have a look at the code, it's just a big list of these declarations, and I thought at the time, oh, that's weird. So maybe what's happening is that we're running out of function scopes, and there's probably a limit to that inside the compiler, which is true. That's actually what was happening. There's a few other things that were happening too, which I've spent the past few days trying to hunt down and trying to solve. Now, here's our really uninspiring demo. All this is a bucket load of code. We're including some big files into our project, forcing the thing to compile all this stuff in one go. Now, what was happening before is that it would break. You would sort of have this, and then that was fine. But once you added anything else, it would just break and either crash or give you weird errors and this kind of stuff. I'll go into why in a second. Let's just test compile and run in this case. Now, initially, this is not the compilation time, this is the IDE bundling up the code. And you saw the compile time there. It takes about a second to do it. So it's built all that code and we're executing it. Here I'm using the load DLL to test that particular DLL for this example. I've just happened to make the bigger test out of that bigger example. I've added an error there to make sure that if load library fails, which is most people who know about Windows, that's how you load DLL files so you can have access to the functions within them. If I try and load the thing with load library, it fails for the same reason, and the error it showed you in the message there, this one down at the bottom here, it's saying that Windows load library failed, and it's returning the last error message from Windows, which is what this 126 is. When I looked it up, it was something about, it's like a file not found, and the more I went and did some research on that particular DLL, it turns out that it's got these dependencies, as in the DX3D dependency. That's not really the point of this whole topic. If we hit compile and debug mode, or hit stop, go here, we can see the scopes. There's a lot of scopes, which is fantastic. Now, getting to what the problem actually was, if you look at the program here, actually that includes a good example, is that inside the compiler there's a series of these kind of pre-sized tables, and the tables are like guessed to be certain sizes depending upon the input source code. So the density of the source code can be different, and then those guesses can be bad. So in this case here, these are all functions, even though they're external functions, they're functions that were being added to this global function table. So we can then look them up in the compiler, and then at runtime we would call this function that it's an alias for. In this case, they're almost one-to-one mapped. The problem we're having, or the problem it was having, was that table was overflowing, and of course then any functions declared after that, but not just functions that declare after that. There was a secondary problem too that turned out to be a bigger issue than I was even imagining. So initially I realized that we needed to expand the function tables if they were going to be overflowed. So we added that sort of support to the internals. And then I was building this and thought, oh, that's great. And it would have these weird errors where on the Flex GUI here, if I added these 3 or 4 things into the code at once, if they were in the code at the same time, it would randomly fail to find this particular label inside the GUI library. Sometimes it would work, sometimes it wouldn't work. So it was one of those ones where you go, oh no, this is the worst case scenario. I was looking at the label stuff, then realized that the label tables didn't have provision to grow as well, so that they were expanded. It would seem like it was building fine, and then all of a sudden it starts doing it again. It's like, oh, this is weird. I'd forgotten about there's a secondary table of patches that need to be made. The compiler generates what's going through the program, and a patch list is applied at the end of compilation to link in the location of things that were unknown during compile that are known at the end of compilation. I'll give you an example. Here's a sort of classic one. Just something like as simple as this. If you have if A equals 100, and if, print hello world or something, sync, okay, all the good stuff, all the classic stuff. Now, when the compiler builds this thing, it's scanning down the code. We see this token at that level. It's just a token. It doesn't really know what it is yet. Goes, all right, what's this word mean? Goes off and goes, oh, that's a command called if. Great. After an if, we have an expression. We phrase the expression. We build a list of operations that convert this expression into a final, a boolean in this case. Actually, it's not really a boolean. We only have booleans. We just have integers that represent. So it's either true or false. And we just consider anything to be that's 0 is false, and anything else is true. Now, underneath all this stuff here, what's actually happening is that the compiler generates a comparison instruction to compare these two things together, and then we have a branch instruction under this for the runtime. I'm talking about this is the virtual machine, and that branch has a forward branch in it. It needs to jump if this is not true, we need to jump over this stuff. We might have, one line of code. We might have nothing in there. Who knows? Or 100 lines, or 1,000 lines, or 10,000 lines. We have to jump over and to this particular location. It's probably easiest if we just think of them as line numbers, but they're actually addresses where the code is. So we have a comparison, a branch not equal here. At this point here, because it knows that it doesn't know where the end of this is, so it generates a closing label for where this is going to occur, because it knows at some future point, if this is valid code, there will be a closing end if for it. So what the compiler does is goes through, goes, oh yeah, got the expression, got the if, put the branch in, generates this closing end if label for this thing here that we're expecting to find in the future. We continue on, phrase the next line, we find a command, bundle up, insert the call command process, next line, do the same thing, blah, blah, blah. Ironically, end if does nothing. It just goes, okay, this is the location of where we need to patch back into the code. And that's what the patch list is all about. So even though, like, you might be surprised that this is how it actually works, it's not unusual. It's pretty much how it's normally done. But the net result is we've got this kind of dynamic list of these patch addresses that's expanding over time. In other words, the bigger the program gets and the more complicated it gets, the more of these locations we need to keep track of. They need to be held, and if that buffer was a fixed size buffer, and the same problem if it overflowed that buffer, classic situation would occur where you're writing off the end of that memory into something else. You don't know what else. I mean, who knows? And as far as I know, this has been a thing in PB for a long time. I mean, an awfully long time. Because when I was adding these couple of expansion routines to these buffers, I went through and looked at some other tables there just to make sure they were correctly sized or sized better, and thought, oh well, these tables are too large. I'll shrink them down. I must have forgotten about what I was doing. Forgot about what changes I was actually making, and continued working back on the expansion routines and made sure they were as efficient as possible as I could possibly make them. Did a rebuild and went to test a live build, and it just crashed, constantly crashed, wouldn't run at all. And I've spent the last day actually with a version of PB that wouldn't work at all. It wasn't until this afternoon that I finally tracked down that in one of the expansion routines, I'd missed out one little fraction of data that, as it turns out, that it's very infrequently used, but when it is used, it was enough to create a buffer overflow, and that was the end of that. Would just crash it. But it was the kind of thing where it was dependent upon what the code did. So if you had, in this case, it was about optional parameters used in functions. So I don't know which ones have optional parameters in them, but before, when I would, just had the test going, it wouldn't even compile hello world, let alone anything else. It seriously took probably 12 hours to find it and work out what was causing it, and then track down what exactly was making this thing do weird stuff, because it was just doing strange things. But once that's been resolved and the labels expansion stuff has been added to it, the function table, I think, is expanding correctly. I hope so. That was where the main problem was occurring, or a few different problems were occurring in it. There's still one more that I can think of, but for the time being, it's okay. And that's the patch address stuff as well. yeah, once it was uncovered, it sprung back to life straight away. Well, pretty much straight away. So I was quite happy about that at the time. It's so frustrating sometimes when you're trying to get through a thing. You're trying to make this as stable as you possibly can. Not just for yourself, but people who want something to actively, test and experiment with programming in. And to run into those roadblocks sometimes is quite frustrating. I mean, it's a valid question to ask. Well, why bother with the old version? Because I just want it to be as stable and as complete as it can be. I mean, tonight I've been running through testing the examples to make sure this thing's actually working the way it's intended. One of the byproducts of making those changes with the expansion stuff to the label structure in particular is that it has improved searching in those things. I mean, compilers are really... The number one thing you do inside the compiler is you do a lot of identification stuff where you see a bit of text and you have to search for it and find what that is and then react to what that thing is, In this case here, you'd see the include keyword and go, okay, we're expecting a file name next and we have to drag that thing off disk and do this other secondary stuff, So what happens a lot is that you're constantly searching through these different tables, and some of the older ones I put time into improving the performance of a while ago. Like this is the largest program that's probably ever existed in PlayBASIC that's actually compiling and running. That initial pause is the IDE doing the bundle. The compile window there is the actual compile time. So she works pretty well. I can show you the code as it's bundled up. So this is, I don't know how many lines this turns out to be. What do we got? Well, it's good 10,000 lines, so that's nice. So if we can get like a 10,000 line per second, that's a pretty good response. That fits in with the plug and play nature of the whole idea, is that you want it to be responsive to a quick change, a recompile and run, a quick change and recompile and run. That's how a lot of people like to work. I like to work that way too, actually. Sometimes I like to build libraries or APIs and then drag them in, but generally I just like to do those things. Right level of the map. There's operations in the secondary these slibs that it's not that they're not only documented as commands, or it's sort of helper functions that became slibs, but because people don't know they're there, there's no reason. They're like a forgotten orphaned cousin or something like that. All right, let's take a look at an older version of 165 and to get an idea of what this thing was doing. All right, I've just loaded 165.10, I think it is. So the last beta that was available. So if I try to compile this with this older build, we'll see how we go. It crashes. Doesn't build at all. I think you've got to pull them all out to make this compile, actually. I'm not sure if it's grabbing those or not. We'll have a look. The IDE preprocess can actually, I think it has a thing where it will read inside comments. I'm not quite sure now. I'm using, yeah, that's probably it. Right, so this is compiling it running. It's the old beta 10. But as you saw, it's unable to build anything that works beyond a certain point. I mean, as you can see, if I add another file to include and hit compile again, it won't run and fails completely. I think internally the function tables were set to like 1,000, which is what this is doing up here. It's going function index. So that value that we see at the start, if it does actually run, is the number of functions that are in the table. So 1,003. So even that's exceeding the internal table. I think it's set to 1,000 different scopes. I don't remember exactly, but you know, at that point, because most buffers have allocations that are bigger than what they need to be. So we might have like an index range of something with a bit of padding on the end of the buffer, because we want to protect ourselves against doing overflows, hopefully. Obviously sometimes that's not the case. What I would like to do with that is actually use the arena based stuff from a few weeks ago that's using the mapping libraries now. That would be much more efficient. Alright, let's switch back to the current build. Alright, we're back in the current build of 165, which is the beta 25 or where it is. Last week was all about, I ran into a problem that had deeper repercussions about the mapping libraries had these bottlenecks of these copying memory around in them, and then so it's one of those things where it's like, well, that seemed like a fixable thing, and it was, and hence building the arena stuff, the array allocation arena stuff. Now, this is something you definitely couldn't do in the old version of PB. So this has tiles that are, I think, about 8 by 8 or something like that, all animated, you know, running it as an FX buffer. It's frame rate capped. The blocks here, so I think you can go down as far as like 4 by 4 blocks for a full screen of blocks, which is pretty insane. Definitely was not feasible before. The point I was actually wanting to get to is that what's made this more optimal is the underlying strategy for memory allocation. Inside the I've been fooling around with the second generation of the compiler on and off with different ideas, and there's things about these things that are problematic. One of them is that need to search all the time is ever present. So you've got to be careful about how you structure the data to make otherwise as programs get larger, the cost of searching becomes exponential. Another one is that because you're creating you're sort of adding to these tables all the time. I'm thinking more, you know, I mean, just imagine like variable tables, for example. For every variable, there's a position in a table and some data about this variable, its type, its position, you know. Yeah, there's a bit of other stuff there too, but basically that's what you keep. But you need its actual name. Later on, when you use this variable again, I can go, okay, that's the same variable. So whatever your operation you're doing upon the variable uses the same bit of memory in the final compiler program. If you had tens of thousands of variables in the same scope, it's a lot of brute forcing to do to find those things. And secondly, those tables grow, they become more and more expensive to expand and store that kind of data. So one thing I was thinking about really was a kind of arena for the compiler, where you've got this larger buffer, and we're using a kind of the array memory allocator kind of stuff approach to use like smaller subarrays, smaller subsections of that larger array, and ideally where I can have a visualization of this thing to see just how heated that table is getting, and look at where it's obviously things are running outside the buffers. But I can add, I can easily add expansion to those tables without doing allocations. In the mapping library, one thing you wouldn't realize is that, so when you create a map, you're creating an internal array of levels. Now each level, just think of it like a one-dimensional array. That array has a handle to an actual grid of data, which is the tiles. The tiles have a specified header of them. So it's just a structure with the data attached to it. That's the most efficient way of storing the data. Because when you do that, the program has really good locality. So all the information about the level that you need to modify the level or whatever is right there with it. Now, there's one exception to that, is that things like animated tiles, they are stored, well, there's actually a few other buffers as well. So the tile map is one allocated buffer. You've got, the map has an array, it's an allocated buffer inside in there. When you import any blocks, there's a structure for each block that represents its transparency and the subsection of the block that has graphics data in it to improve. So you can look at a tile and go, do we have a collision with this tile? There's a whole subsection of this thing that's underneath that no one would have noticed, because that was built years ago for those collision commands. That there's lots of them there. They're not brilliant, but they do a pretty good job, and that's the best you can sort of hope for, I think. There's a secondary array of the status of or the type of block each block actually is. And there's animation tables where you've got like an array of animations, and then you've got each animation itself is an array itself of this variable length. That's why we need the allocator for maps. So if you have multiple maps of multiple levels, there's a lot of stuff going on. I mean, you could do it all in one, just one array, because really that's what we're doing. I'm calling it an array, but it's just a buffer of memory, but the principle's the same. It's exactly the same principle. You can just, your array and memory are the same thing. There's nothing special about this stuff. Arrays in PB is just a header with the raw data following it. That's it. There's exceptions to that basic definition where you have secondary bits of data that represent things about, like the order of cells, for example, or typed arrays, or string arrays are probably a better example. Like a string array, the text isn't stored in each particular cell. It's just a handle to an allocation of where that text data is. So if you want to read the thing, you read that position from the array, grab the handle, ask the memory system, hey, where is this text in memory? Where the hell is it? And it's done that way to avoid potential orphan pointers and There's a lot of other problems that can occur with that stuff. It's much safer, and the string engine can perform optimizations about strings that wouldn't be possible otherwise. That's neither here nor there. The point I'm trying to get to with this allocation layer is that system has one single underlying method about growing the data. I don't need to write special occurrences for any kind of data. I can just expand those buffers at will, and it just does that for me. So it's simpler, less code, better reuse, of course. The locality of all that data, everything's packed into memory near each other, which is much better in terms of performance for looking up things. String data is a classic one, is that because you've got these things that are in different parts of memory, fetching a small string can be quite expensive to actually do. I mean, you could bend over backwards to do that stuff, and I've tried this in the past. You probably don't remember this stuff. There's a whole conversation about this caching system that was in one version of the VM, but I think it was too broad. It worked well for certain examples, but turned out to be slower for other examples. It's unfortunately a lot of these kind of optimizations turn out to be like that, as they don't turn out. It turns out that in some situations it's better, in most of the time it's probably the same, and then other times it's probably worse. So you're hoping to be overall better, but it doesn't always go that way. Anyway, the point about the allocator stuff I'm trying to get to is that that would be very useful for things like variable tables, and we have some kind of make the structures a bit more dynamic, I guess, without them actually being dynamic, which sounds kind of crazy when you think of something like that. But we do away with real-time allocation for the most part. We do need some allocation here or there. We have arenas that are linked to other arenas, so if one is completely full, maybe it's better to just allocate into a new arena for newer buffers and let the system handle those things for us. In other words, as far as the code above it's concerned, we don't care. We're just going, hey, give me a blob of memory that you're managing for me, and let me get a pointer to it, and let's write some data into it. Let's go. And it just gets rid of a lot of this redundancy. There's a lot of this kind of common stuff that happens in these things that, honestly, sometimes you just go, why is this even a thing, The one that works in PB now, the one that's actually accelerated the map libraries, like the test that uncovered this stuff originally, how slow the allocation stuff was just inconsequential. It was like, we'll just try and make a few levels to test something, and then it's like, wow, it takes a long time to do that, and then it was taking like a few hundred milliseconds to do it, and so that's a bit weird. And all you had to make was a handful of these maps, and that was it. You were stuffed. One thing we do have now too, while I'm actually here, so this map, new map, we've provisioned for like 10 levels. So if you did something like this, to 100 levels or 1,000 levels, and you wanted to go new level, and this level is this tile map is part of in here, so we're asking for a free index from here that's currently not used, and we want this thing to be width and height, and we just bump those up as we go through. So bump them up. I think in the original test I was set to like 100 by 100, so that's about 10k for each one. Now this should fail and I wanted to fail to show you something. We'll try it, see how we go. Yes, that's correct. So the internal buffer, the AMA system, has a physical limit now, and it's prepared to fail at runtime and then return errors back to you to say, hey, this thing is actually out of control allocating memory. It's going to crash the program, but we've got a message for you here. Originally, it didn't do that. It would just crash. Silently, boom, thing just died. So let's just see how many of these things we actually can create. Print lev before it does die. So we'll try 400 into our console. Seems like that's doable. Okay. Try 500, which is the magic number originally. It wouldn't do that. Yeah, there we go. That's the kind of stuff, the kind of quality of life things that you want these things to do. You want it to pull you up when you're doing something that's bad for your health. I think the table is set up to be, I'm not sure now. I think it's set up to be in size. I think it's 3. It's this many bytes. So you potentially you've got 67 million integers that this can be in size, because internally each cell is actually 4 bytes. So you allocate memory, you divide the size by 4, and that's how big the allocation is inside the AMA. For most things, I don't really care because I'm doing tile allocations, but there can be an uneven number of bytes. It doesn't matter, because as I said before, you got a handle to this thing, you've got a pointer, you're writing the data. As long as you don't overwrite the end of the end address of your allotment, you're perfectly fine. Yeah, that's an awful lot of memory. not to put too fine a point on it. So effectively, what that means is it's this to the power of 2, or multiplied by 4, I should say. Yeah, it's an awful lot of memory. It's a lot. It's about 2 gig. So that should never actually happen. Now, what I would like to do is utilize that same system in other places in the legacy command sets to take away some of the real-time allocation burdens that are in those commands. One you wouldn't be aware of is that sometimes you need to allocate temporary data for things like collisions. It's a bit of a classic one, actually. But anyway, I've spoken way too long. But this is real progress is being made, but none of this stuff is kind of show-stoppy sort of stuff, the kind of thing that's going to bore you to tears. And for better or worse, most of the conversations we're going to be having about this for the rest of the year, I would say, are going to be technical. And they'll be more and more technical, so hopefully you don't get too lost, and hopefully those people who are wondering why things are a certain way can get something out of these things. Just one word on the example pack. I've picked through a lot of the examples, and as you can see, I've been going through them one after the other. I've made a few changes to a few of them, not substantial. In other words, they're not dramatically different. I mean, most I've just added a space bar to exit them, change some of the controls, and some of them. A handful don't work out of the box. I know Steve's been through those a good year ago now, 18 months ago. I don't know when this was now. Such a long time ago. So I'll have to pick back through those. And I've also changed them to so they're not actually full screen exclusive starting up. They're just windowed by default. I think it's more appropriate these days. A lot of them, like on my laptop now, they perform very well. Like really, really well, generally. So that's always good. There's the odd one here and there's doing some weird stuff, but there's some old demos there that are kind of fun to see. Like I'd forgotten a lot of these things. There's a little TV thing. Yeah, it's kind of cool. And this was written way back in the early days of PB, so it would have been like 1.06 or something like that. So maybe it doesn't have most of the modern features. Like there, it's using. Let's see if we can actually change that to an FX image. It shouldn't make much difference to it. I mean, back in the old days, you couldn't render text onto FX images, so the way that works, by the way, is that if it notices you're trying to render a text onto an FX image, it does an entire font conversion for you there and then, and keeps that in a temp buffer while you're rendering. So just imagine that stuff. Like that happens so frequently where to make something work, you've got to bend over backwards to keep the illusion of something going. I won't miss these legacy APIs, to be honest. I won't miss direct draw. That will be nice to get rid of it and just add the space code to that one there, unless that was used for something else, was it? What's the classic one there? We're using scroll image. Probably not a great way of doing that. I'm not sure how that's implemented internally, but I've got a feeling that that's got an allocation in it. I think it allocates a temp image at some point and then does that. So to do this stuff in user space, you're probably better off having two images and you're copying from A to B to make the scrolling occur. That I wouldn't be surprised if that's quicker than the internal command. Yeah, because unfortunately a lot of times the internal commands have to be kind of very safe about what they do and how they do things. Anyway, I've spoken long enough. You've got a rundown of the new version. We've had some really good success, and I'm very happy with it. Happy with the performance of the whole thing at the moment. It really does feel very instant. So, which is really what I want. I just want it to be quick and easy for people. I'd love to spend a lot of time on the old compiler. Every time I look at it, I'm just like terrified, frustrated in some regards, and I'm tempted to make improvements. I know that when I was doing the 165 translations originally, which is the newest version of the runtime, so this kind of runs on the second generation. I'm not even sure what we'd even classify that now as. Is the new instruction sets, or as in terms of efficiency, it's pretty good. There are definitely places where it could be better, and that's what I'll tackle with PB2. But I want to get this finished first. I didn't want to do a bit of both here and there, and shimmy around, because I want to use this as the test base for that. And if we can share code between them, great, fantastic. You can get benefits from that, on the same day. But if we can't, fair enough. Yeah, fair enough. It's all right. I'll leave you with the scrolling demo. Thanks for watching, and I'll see you next time. Bye.